Hi, everyone. Welcome to another session of the Almudena track here at JNation. For this session, we will have Elder Moraes. He comes from Red Hat, and he's going to present us your Java application cloud native ready, a live experience. So it's going to be live coding. Is it, Elder?
Yeah, a lot of live coding. Looking forward to it.
Okay, so I hope you have sacrificed some lines of code to the gods of the live demos, so it goes well.
Yeah, otherwise we're gonna have some fun about me, so that's fine.
Sure. So go for it. I'll see you for the questions later.
Okay, so thank you, Bruno, and thank you everyone who are attending to this amazing event, JNation. I'm very happy to be here. Unfortunately, not yet at physical presence, but we are still doing what we can here. I hope you are all safe and sound. Okay, guys, so let me share my screen with you. As Bruno said, let's talk about Java code at cloud native age. Okay, so how can we make Java work at the cloud native approach? All right, so to get started here, to warm up our engines, I would like to run a quick demo with you guys. Okay, and for that, I kindly ask you to go to this website here, demo.eldermoraes.com, or please, you can also scan with your cell phone or just go to the URL. And if you can do both, it's interesting as well, because at some point of the demo, our application will behave differently if you are using a mobile phone or a browser. So it will be fun here. All right, so I will give you like 10 more seconds to access this application here, demo.eldermoraes.com, or please scan our QR code. Okay. 5 more seconds, and then we are good to go. All right. So welcome everyone again, if you are just coming here right now. And probably if you are accessing this application, you are seeing something like this. Okay. This, let me refresh here. Okay, so this is our application. It should be changing. It's not changing. So Bruno, it's all right. I should have offered some sacrifices before. Let me check here. Okay, now it's great. Okay, so maybe if everything is working on your side, you are seeing an application that sometimes is green, sometimes is blue, sometimes is green, sometimes is blue. What we are working here is what we call a blue-green deployment. Okay, so actually I have here two different applications. One application is green, one application is blue. And this is a Java application, of course, a very simple Java application. But this application is built and deployed following a lot of cloud native approach. So basically here I have a service mesh. I have I'm deployed, this application is deployed on a cluster that is orchestrated. So I have a lot of good practice, best practice that it's recommended for cloud native applications, okay? So what I'm gonna do right now is to deploy another version of this application. It's another application actually, but I will put this new application on the same load balancing, okay? So I have one blue, I have one green, I will have now a yellow or a canary deployment, okay? So let me go just and do this. Okay, for the sake of the time, I will not get in too much details because the details are reserved for the demo part, okay? So for the live coding part. Now I have the canary. So if the gods are happy right now, maybe we will have a yellow application appearing sometime here right now. Okay, now we have the yellow. Okay, so why not? Right now I have three applications: blue application, green application, yellow application, and all of them balanced in this gateway here. Okay, So one thing that I could do, for example, I can make all the requests, and let me just check my scripts here. Okay, 7 blue. Okay, so just go here, for example, and change to blue. So once this script it's done here, I can make all the requests going to the blue application only. Okay, and if you notice, I can change the way that my application behaves without changing its code, because the way that it was built, that's the fun part and the smart part here. I can also change for green application. Okay, so now everyone it's going to the green version. And finally, I can also change to the yellow application or the canary application. Okay, so now everyone going to canary application. All right, now here comes the fun. I can, for example, do this. I would change everyone using Firefox to the canary version, and other users will stick with the green version. So let's just apply the script here. Okay, this is a Chrome, okay, a Google Chrome, as you can see here. Let me get my Firefox here. I will open my Firefox here on demo.eldermoraes.com. I have some issue, whatever it is. Let me get a private window, demo.eldermoraes.com. Okay, some cache, no worries. Okay, so the Firefox, it's stick with the canary version. All right, so right now I will make another change here. I will move everyone that's using Android. So if you use it your cell phone and you are using an Android, right now you will just see the canary version, and everyone else will stick with the green version. So let me change here. Okay, so Firefox using the green, and okay, and let me go to Chrome. Okay, Chrome here, it's on green. Now everyone using an iPhone, it will stick with the yellow. So if you are using right now an iPhone, you will see the yellow, and everyone else, as for example here, it's in Chrome using a green. And finally, everyone using a mobile will stick with the yellow or the canary, and everyone else is still using the green. Okay, just a quick demo, guys. I will, because the service mesh part especially is very huge. So just would like to give you a final experience of an application using some approach that I will show you right now. Okay, so thank you for the help with the demo. And right now, let me go back to my slides here. Actually, I almost don't have any slides, okay? So I will just open in a second. Okay, demo. Okay, and that's the demo that I just showed you. And just to introduce me very quickly, my name is Elder Moraes. I work at Red Hat as a developer advocate. I'm based here in Brazil, São Paulo, and I'm running the Red Hat Developers Program for Latin America. I'm a Java champion, I'm a developer advocate, I'm a board member at SoulJava, one of the biggest Java user groups in the world. I published the Jakarta EE cookbook. If you are working with Jakarta EE, maybe my book is interesting for you. And my mission here and as a professional is to help Java developers to build and deliver awesome applications. All right. So no more slides. Let's go back to the code. All right, guys. So what I'm going to do right now is this. I will build an application using microservice approach, using containers, and using REST clients and adding some health checks, some, well, a lot of stuff that we're gonna build right now. To gain some time here, I built some code before starting this session. And right now I have an application running here. So let me show you some stuff. I will make it bigger. And this one also bigger. Okay, so here I will just make one change. I will change to, because I'm connected to a Kubernetes, okay? My Kubernetes is running on AWS because we will work with Kubernetes also today. Okay, guys, I have here an application that is managing some fruits, all right? So I will just show you very quickly how this application works. So basically, let me get here what did the other guy, this guy here, okay. Okay, right. So basically, for example, oh, I have an error here. Let me stop here. Okay, so the gods, them are not happy today. Okay, let's launch the application. Okay, good. Let's go again. Okay. So I have an application that is managing fruits. So if I get this very same URL here and go to my browser, and I have these fruits here. Okay, mango and strawberry, and both of them are from Spring. Let's see this code just to show you what is happening here. Basically, I will close these guys here. Okay, I have an entity. It's a fruit. It has a name, and it has a season, and this is a panache entity. And I have here a custom method, a custom finder, find by season, where I pass any season and I get the results. And I have also a fruit resources, a REST endpoint, okay, just easy peasy. And I have here a list of fruits. If I pass a season, I will return, find by season. If not, I will just list my entire entity. And I have here another method to create new fruits, okay? Just to, and all my lists of fruits are coming from this insert here, just to have some more data. Okay, guys, so let's start making this application here more fun for cloud native reality. First thing that I would like to do right now is to get this application and deploy on my Kubernetes, okay? And if you ever worked with Kubernetes, you know that it's not exactly something easy when we think about building all those YAML files, okay? So yes, Kubernetes is powerful. It will make your life easier, but to get your application up and running, sometimes will get you some more enforcement to build, especially the YAML files, okay? But if you are using Quarkus, if you are using the best practice for Java with Cloud Native, your life will be easier. And as this application is using Quarkus, I can add all the features that I need. I can add these features using extensions. So first extension I'm gonna add right now is the Quarkus Kubernetes and the Quarkus Container Image Jib. What those extensions will make for me? The Quarkus Container Image Jib will help me to build an image for this application without needing to create a Docker file or maintaining a Docker file, okay? And this other extension here, Quarkus Kubernetes, will help me to get this application and deploy on Kubernetes without need to build an YAML file. I will have an YAML file, but I don't need to build this YAML file, okay? So what I'm gonna do right now is to, okay, I added those extensions. Right now, I need to add some properties to my application properties file. So basically those properties. So I will connect to the Docker Hub. I will connect to my account on Docker Hub. I will deploy this image from this application I'm using right now. This is the version. And when I deploy this application to Kubernetes, I will create a load balancer. So it will create a service of a type of service of a load balancer. And this is just for certificates because I will not using SSL here. Okay. All right. So let's just here connect to my Docker Hub and hope it will work because another day Docker Hub was out of work. Okay, right now it's working. And simply this way, I will use Maven to package my application, but I will use this option here, Kubernetes deploy equals true. If everything is fine here, it will compile my classes, it will package my application, then it will create a container image, it will push to my account on Docker Hub, and then it will run a deployment, my deployment on my Kubernetes using this image, and then we have this application running on my Kubernetes, okay? 20 seconds, not bad. Let me check if my application it's already running on Kubernetes. Okay, 16 seconds, it was created. So if I have the pods, probably I have the service. Okay, I have the service. Usually this external IP, this DNS here, takes around 1 minute, 2 minutes to be available, but let's try. Sometimes I'm luckier. So hello. Yes, it's not working. So we'll keep it running here while we go forward. I will leave .3, done. Okay, so around 1 minute, 2 minutes, it will be available. All right, while I try to reach my application that is already available on my Kubernetes, I will keep my live coding moving forward here. All right, guys, so let's do another stuff. I have here an application that's managing fruits. So at my laptop here, I have a small database with the season of a fruit and a name of a fruit. Now I would like to have more data about each fruit. And I discovered that there is a service, a remote service somewhere. I have an URL for this service. And if I pass the name of my fruit, it will return me more data about these fruits, okay? So I like this service and I'm gonna do, oh, now it's returning here. Hello, rest easy. Okay, it's the reload of my application, okay? If I tried the fruit, of course, it will be empty. Okay, but yeah, so it's available. Okay, so I have my application running on my Kubernetes right now. Oh, and before trying to create this REST client, let me show you how this application was deployed on Kubernetes, because this is the most interesting part of this session here. When I use it, that option to deploy my application on Kubernetes, just because I have this extension on my application, when I try to package this application, I have this file here. Code target Kubernetes YAML. Okay, let me open. This file was created by the plugin, in the process of packaging this application. So if you notice here, if you ever worked with YAML files, this is a usual YAML file for deploying an application on Kubernetes. But the best part is I didn't have to create this YAML file because the plugin made it for me. So I have here the service, I have here the name, I have here the port, I have here the name, the kind of service is a load balancer. Here the deployment and the name of the container specification. So the image that was created. So everything that I need to deploy an application inside a Kubernetes, it was made by the plugin, so that I didn't need to touch on this file here. And each time that I add something to my application that needed to be known by the Kubernetes, it will change this YAML file here accordingly, so I don't need to maintain this file. So it's very, very useful. Okay, guys, so as I was saying right now, I will just create a REST client here to have more data on my application. Okay, so no, this is not the case. Let me get here. Okay, so I will add a extension of REST client. This is from MicroProfile. Okay, so just using plain MicroProfile here for creating a REST client. And right now, I will use an external service called FruitVice. And for that, I need to create some new classes on my application, okay? Guys, I will not get into too much details of what I'm doing here because it would take much more time. And I don't want to show a lot of details instead of show you what can you really do, okay? But let's go. I will just create a module here. And then I will create my interface that will be my REST client. So let's create this guy here, FruitVice service. And this is my interface. So this is actually our REST client. So, okay, so just a simple MicroProfile REST client. I will register this interface. This is the method that I'm going to use. And right now, I just need to inform the URL of this service. So I will open here this guy. And okay, here. So if you can check later, this is fruitvice.com, and then you will see how you can use it. All right, but don't worry right now. Of course, I need a DTO to make the transformation of the data that I will get from this service. So let's create this guy here. And finally, I will change my REST endpoint to FruitVice. Okay. Because right now, okay. Now I have here my REST client injected on this endpoint, and here I'm using it. So just this guy here. So here I'm passing a fruit name, and I will get more data for this little application here. Okay. If everything is working and I didn't mess up, so let's try to access this application again. I will make it a little bigger and a little bigger. Okay. All right. So let's try to access. So right now it takes a few more seconds because I'm accessing a remote application. But I have here. So I have the name of the fruit. I have the season of the fruit. And now I have also carbohydrates and calories from this remote service. Okay, so this is a way of two microservices, for example, to communicate to each other by using REST in the client. And the best part is you are just using whatever you already know, okay? Because it's also it's not something new to Java. It's all something that we're using a lot. Okay. So right now, let's move to fault tolerance. So let's add some features related to fault tolerance here. And for fault tolerance, I will also add a new extension. And this is the fault tolerance API from MicroProfile as well. Okay, most of stuff here, it's based on MicroProfile APIs. All right, so what I'm gonna do right now is to make some changes to my my REST client here, the interface that we created for this REST client. So basically, I will make the one test here. I may add this feature, retry. What is retry? If this application, if this service specifically have some issue, some problem to access some stuff, I don't know, some error, instead of just return the issue, return the error, return the message, it will try again. How much times? At max 3 times, and wait 1 second for each try, okay? And for make this really have some issue, I will change this URL here for blah, blah, blah.com, okay? So let's try to access again. Okay, too fast, so let's just, okay. Ooh. Okay, restart the developer mode, and then we call it again. All right, so this application is taking too long to bootstrap, like 3 seconds, 4 seconds. Okay, so yeah, 4.67 seconds. Okay, let's try again to call the fruits. Okay, now I have, because it tried once, 1 second, tried once, 1 second, and tried twice, a third time, 1 second again. And right now I have here unknown host exception, blah, blah, blah.com. Okay. Okay, so I have one improvement here because I didn't return the issue at the first try, but it's not good, as it's not yet good, because return this kind of error to your client is not something that you should know, you should do. So what you're gonna do right now is to add a fallback feature here. So let's change this REST client again. And right now we have the retry, but also we have the fallback. So the fallback here, I'm creating a class. I could use a method, but I'm using a class. So this class will implement a fallback handler, okay, of a fruit device. And basically, if I have some issue, I would just return a fruit device that is empty, okay? So no data on the data that was expected, okay? Good, so let's try again. I will call this application. So you try 3 times. And then in the end, we just return a empty fruit device. All right, so, okay. Come on. Yeah, I have a lot of stuff running here on my machine, so sometimes it takes too long. Okay, so I have name, season, and carbohydrates and calories are 0 because I couldn't reach that service. And for this demo, I decided that if I can't reach that service, I would just return an empty entity, okay? Of course, for your business purpose, you will treat different, okay? If I just return this guy here to the correct URL and call again, hopefully I will get the data. Okay, so right now I have my data here. All right, good. Let's go forward. Okay, guys, what I'm gonna do right now is to work with health check, okay? And for doing that, I will, of course, add a new extension. And the extension that I'm gonna add right now is health, also from MicroProfile, okay? So let's just add it here. And one interesting stuff about the health check, the health API is this. Let me show you. I didn't have to create this endpoint here, but just by adding this extension to my project, it's already available. Okay, so this is a default endpoint for this API that's supposed to give the information about the health check of my application. But of course, this is not actually useful, but so let's just create our own probes. Basically, when we are talking about orchestrated environment, we have two kinds of probes. And I will change here to my camera to explain to you. We have two kinds of probes. We have the liveness probe and we have the readiness probe. What's the difference between them? The liveness probe will tell to the orchestrator if your application is live or is not, okay? And the readiness probe will tell to your orchestrator if your application is ready or not. What's the difference? Now, suppose that I am a service, okay? So I'm here working, and then the orchestrator asked me, hey, are you alive? And I say, yes, I'm alive. Okay, are you ready? Oh, let me check. I need to access a database. Oh, the database is not available, so I'm not ready, okay, for example. So if I'm live but not ready, the orchestrator will not send requests to you or to your service, of course, okay? But at the other hand, suppose that I'm a service and then the orchestrator asking me, hey, are you alive? And I don't respond because I'm not alive, okay? What happens in this case is that the orchestrator will kill this process. In the case of Kubernetes, will kill the pod and then we'll create another one, okay? In the other case, if you are alive but not ready, the orchestrator will just wait. And then in a few seconds or minutes, I don't know, it will just ask again, okay? And if you are ready and then you are, if you are live and ready, then you are ready to receive requests, okay? Just to explain to you. And then let's add our probes here. So we'll create a liveness probe. This is the liveness probe. The liveness probe, it's the easiest because or you are alive or you are not alive. So, but just to understand the structure of a health check probe, you implement the health check interface. You will also be using the liveness annotation, and then you implement this method here. And for liveness, usually you just return, hey, I'm alive, okay? But the readiness, as I just said, is where you are gonna maybe put some kind of business rules or something like this. Okay, so just readiness probe, and it could be, for example, if I try to access this service that I'm, it's wrong here. You are here, and you are here. Okay, good. Basically, for example, this service that I'm accessing to bring data about my fruits, I could, for example, check if this service is available, if I can get data from it, so something like this, okay? So here for this demo, we are just making some simulation of accessing a database, okay? Just for demo purpose. Let's refresh here. So right now I have the return of my liveness probe, and here the return of my readiness probe. All right, so now we have, and the interesting part, let's make some stuff here. MVN clean package, just a regular clean package, okay? We'll package this application. As I have this extension of health check, and I have my health checks defined here. If I try to access again my Kubernetes YAML, right now I have here, I have my liveness probe, and here the endpoint, and I have here my readiness probe, and here the endpoint. So it's amazing that I don't need to put it and to maintain it manually. All right. Right now, let me check the time. Okay. Let's work with metrics. Okay, so I will add, guess what, the extension. I will use the micrometer here. I will add this extension of micrometer. I will make a little change on my POM file. Where is, okay. Later, okay, whatever. Oops, okay, so for this one, I will create a new resource just to isolate the metrics here to make it easier to check. So time resource, and then this is the code of our time resource. So basically, here I created, for this method, I created this metric. So it's a counted metric. What is a counted metric? Is a metric where each time that you call this this method here, it will count 1, 2, 3, 4, 5 for each time that is called. Okay, easy peasy as well. I will call this endpoint here a few times to have data. So okay, it's not yet available. Sometimes you need to reload the developer mode. It's not common, but sometimes you need, especially while I'm adding a lot of new extensions here. But it takes like 4 seconds, 5 seconds, so it's not a problem. Okay, 1, 2, 3, 4, 5. Okay, so should be 25 times. And right now, I would just call, as I have a default endpoint for Health Check, I have also a default endpoint for metrics. It's called, guess what, metrics. And then here, if I just try to find here, I have my metric created here. Time now total, and I have here 25 times. Here my package. Okay, so I can check. Of course, you're not gonna using a browser to control your metrics. It's just for demo purpose. Okay, so here is how you can add, create, and realize that I'm adding stuff that you should be using when working with application using cloud native approach. So I have here communication between service. I have fault tolerance features. I have health check features as well. You also need some metrics to work with observability and stuff. And right now, I will add some reactive features for our application, okay? And I will use 2 approaches to do that. The first one is I will add the API that Quarkus use for working with reactive is the Mutiny. So I will create another application inside this project right now. We've been working with fruits so far. Now we will work with beer, okay? So if you like beer, put on the chat hashtag beer, okay? I can't see the chat, so you just do that. Okay, so let's create a beer Pojo here. Where are you? You are here, okay. Of course, again, I will not get into much details about all the data from this Pojo because we need to finish with more information as possible. So I will create another REST client here. Okay, so again, we have a REST client. I have here a list. I have here a beer and so on. And we will again connect to a remote service. But what's the difference between this service and the last service? This service that we will use to bring my beers to my application right now, this service will not return data synchronously. It will use pages structure to return this data. So I will listen to this return and use a reactive way to get it to my application. So let's just be a resource. Okay. So I have some difference here. I have again my REST client. Okay, so no news here. But the return here is the multi, is the return used by the multi API that I'm using right now here, okay? And of course, I will iterate to this return until it is empty, okay? And I will just return those beers who have the alcoholic level of beyond 15, okay? So really, really alcoholic beers. Okay, if I didn't mess up, right now, I can have my beers working here. So, okay, it's supposed to reload it, and let's just wait. Okay, so I have here this beer here, the end of story, tagline, the world's strongest beer, 55, wow, it's really, really alcoholic, and other beers here, a lot of good beers, I hope so. Okay, so this is one way of working with reactive. But of course, there are a lot of interest right now about reactive streams using Kafka. So let's do this. And this is the last part of my presentation right now. I will, of course, add a new extension here. Okay, it's done. Good. Let's go. We will start working with fruits, then we move to beer. Now we are going to work with wine. So if you like wine, just put in the chat hashtag wine. And I will create a Pojo as well. And this Pojo is a little more complex because I have two entities here, one entity for the wine, the other entity for the prices. So the priced wine, this will make sense in a little bit. So let me just create the Pojo. I will have what we call a wine generator here to keep sending data to my topic on Kafka. Okay, just create this wine generator here. It will randomly create a list of wines and prices of these wines. I will, of course, have a resource. This is my endpoint. So I will create this guy here. Wine resource.java. And okay, so here it will use this channel on Kafka, okay, priced wine, to bring the priced wine, and it will just return here to this. Also here I'm using the same API, the Mutiny, but here integrated with Kafka. Okay, so I will create some properties again. So, oops, okay. So here, basically how I will work with the Kafka. I will not get into too much details because we are 5 minutes to go. And right now, of course, I will not create a Kafka on my machine here, but I will use, it's a Kafka, okay? I will just use Docker to build a Kafka broker here. So cd git live tutorial, I will create a Docker compose file, compose YAML. Oops, sorry. No. Wow, don't say, okay. My bad. Okay. Clear code Docker compose. Okay. Now we are talking. Then I get, oops. Okay. Whoosh. Okay. Okay, so basically I will just run a Zookeeper and a Kafka to make it run. Docker compose up. If I didn't mess up again. Okay, yes, should be. It will download some stuff from Docker, okay. Let's just wait to be ready. So they are connected, and then creating data here. Okay, it's connected, it's connected. We'll reload this guy here. Hope the application and our Kafka are connected to each other. Okay, yeah. Okay, sounds like they are they are talking. So right now, I will invoke this new endpoint and hope that we get some wines. Okay, we get wines. Okay, so we have here our Kafka Broker connected to my application and bringing some beautiful wines to our list here. All right. Well, 3 minutes to go. Let me just go back to my slides to show one last stuff here. That is our developers.redhat.com, where you can find a lot of content about Java, containers, microservice, Kubernetes, Linux, and everything focused on developers. If you would like, you can register on this website so you can receive our newsletter, notice about events, especially from JNation. I have here my my image of JNation. Let me here my JNation. So a lot of events that we running on JNation right now. Bruno, I don't know if you have time for questions, and if we have.
We have a small time for questions. I have one for myself. So
okay.
So MicroProfile health check. So we have the liveness and the readiness checks. Mm-hmm. So the liveness usually for, well, I'm here, the service is live, and then the readiness to check if all the things that the service needs are up and running and if it can start receiving load. But there are kind of checks that you only run on startup that are a bit dubious. Are they liveness? Are they readiness? For example, how would you label a check that just verifies if you can, if your passwords are correct and if you can connect to some place and you don't need that afterwards?
Mm-hmm. Yeah, it's like a business check. It's not really a architecture check, I believe, maybe. But yeah. If this is, for example, on your, you could put this kind of check on your readiness. So, well, you didn't pass a correct password for me, so I'm not ready. I can receive.
Yes,
so
yes.
Could be some, for
example. But it's the kind of thing that you would need to tweak in order, for example, not to run all the time.
Yeah. You can, if you have time here, I can share my what is my Kubernetes? You can define the time, how the period when you run your for example, this one will run on each 30 seconds. So for example, you can put on, I don't know, 300, 5 minutes, 1 minute to 1 hour, I don't know. So you can change this guy here to make it, or on each 1 second, I don't know, the kind of application. So you can tweak this to make it to run for your purpose.
Okay, so we need to wrap up. Elder, thanks very much. It was great to have you here, and I hope we can see each other live on a future edition of JNation.
Yeah, I hope to be in Portugal next year. So see you.
See you. Bye-bye.
See you, man. Thank you very much. Thank you, everyone. Bye-bye.
Bye.